Find the intersection of the two planes phi x plus 2y plus 2z equal to 2 and phi x plus 2z equal to 4. So one method we can do is to solve the system of equation. So we have two equations correspond to two planes. So the intersection of the two planes so contain on the points x, y, z such that x, y, z satisfy both equations. So say method 1. So let or if the point x, y, z is on the intersection of the two planes, then we have x, y, z must satisfy the two equations. So this one gives us phi x 2z. So we can take the first equation minus second equation side by side. So we have 2y equal to 2 minus 4. So 2 plus 4, 6. That means that y equal to 3. And the second equation, we can keep one among the two. So if x, y, z is a point on the intersection of the two planes, then x, y, z must satisfy these two equations. This gives us, so let's say this equation 2 is equivalent to 2 phi x equal to minus 2z minus 4. So we bring 2z to the right. This gives us x equal to minus 2 divided by phi z minus 4 divided by 5. So we have x, we have y, and we have z. So the point x, y, z on the intersection has the form minus 2 divided by 4 minus 2 by 5 z minus 4 by 5 y equal to 3 and z just a parameter. So for each point, for each value of z, we have one triple x, y, z. So this gives us, say, minus 4 by 5. We just split this into 2, 3 and 0, plus minus 2 by 5, z, 0, z. So we just split all the numbers out there. The rest is the one depend on the parameter. This one is minus 4 by 5, 3, 0, z, minus 2, 5, 0, 1. So this point corresponds to the position vector x, y, z equal to, this corresponds to the initial point. So it corresponds to initial vector OP. If we think about the line, it has point P here, P of this coordinates, Q is correspond to the point x, y, z. So this is vector OQ, this is vector OP. Minus 4 by 5, 3, 0, plus z, and minus 2 by 5, 0, 1. And this one, we can think of z as a parameter. So the vector equation is r equal to minus 4 by 5, 3, 0, plus a parameter. If we don't want to use z, we want to use t as usual, then this is 2 by 5, 0, 1. And actually st is a parameter, and t belong to r, the set of the real number. We can make it nicer if we want. For example, say r minus 4 by 5, 3, 0, and we can choose the direction. So this is a vector that this line is parallel to this vector. So we can choose this vector like say 4. If we multiply everything by 10, 5 times minus 5 times 2. So minus 5, so we have 4, 0, minus 10. So this gives us the vector equation of the line we need to find. There's another method. So we have two planes. So they tell us that there are two planes, and the two planes intersect at a line. So this is the line of the intersection. So these lines, we can pick one. Say we can choose one point. So we want to find the vector direction of this line. Let me call it L is a line. So note that this line, this vector is on both planes. So on this plane and this plane. So it must be perpendicular to the normal vector of this plane and perpendicular to the normal vector of this plane. So say if we call this is V. If V is the vector direction, or is a vector in the direction of the line L, then V is orthogonal to the normal vectors of the plane, say A, and the plane B. A is this plane and B is the other one. Normal vector of A and V is perpendicular to the normal vector of B. So A and B are the two planes. And you know that the coefficient of x, y, z give us the normal vector of the plane. So the normal vector of A is 5, 2, 2. And the normal vector of B is 5, 0, 2. So coefficient 5, 0, 2 of x, y, z. Okay, and we know that V is perpendicular to both of these two vectors. So V is parallel to the cross product of the two vectors, because the cross product of the two vectors is perpendicular to both. So V is in the same direction as the cross product of, say, N1, normal vector 1 and normal vector 2. N1 cross N2. So as V is just a vector direction of the lines, we can choose V equal to N1 cross N2. So we choose V equal to N1 cross N2, because the direction of the lines is the same direction as its cross product. So N1 cross N2 is I, J, K, phi 2, 2, phi 0, 2 determinant. I 2, 0, 2, 2, J, phi 2, 2, K, phi 2, phi 0, I 4, J 0, K minus 10, 4I 0J minus 10K, or we can write down as S4 0 minus 10. Actually it's the exact same as we did. We try to get a nice formula for that. So we can think of these vectors, the direction of the line, and actually the direction of this line, you can choose this vector or this vector. So it doesn't matter. But in our case, we have this 4, 0, 10, minus 10. And now that is the direction of the line. Now we need a point on the line. So we can just pick an arbitrary point satisfied with 2. So now 2, a point, say x0, y0, z0, satisfy both equations, say star. Such that phi x0 is 2y0, z0 equal to x0, z0 minus 4. So how do we choose that? For example, we can choose, say, as we did before, we know for sure y0 must be 3, right? So let's take the equation 1 minus equation 2 side by side. We have 2y0 equal to 2 plus 4 give us y0 equal to 3, and from equation 2 again coded 2, we have phi x0 plus 2z0 minus 4, and we can choose say z0 equals 0. Then we have phi x0 plus 2 times 0 minus 4. This gives us x0 minus 4 by phi. So the point x0 minus 4 by phi minus 4 by phi, y0 3, z0 0 is on the line. So now we have one point on the line and the direction of the line. This is a point on the line, and this is the direction of the line. So the point has a direction parallel to this vector has direction. Say v equal to this. So this gives us the vector equation is vector r, the position vectors of a point, say q on the line, equal to vector op minus 4 by 5 3 0 plus t, a parameter, times vector v 4 0 minus 10. You can say wait, this is just a parameter.